The number 7 on the test review says to graph these parametric equations, find the parameterized curve. It says to first eliminate t and then draw the picture. So this is a sine and cosine problem. So we'll use the trick where you square both sides and add the equations together. But first, I'll need to subtract a 1 and add 2 and then I think I would like to divide out by 2 or by -2 and by 1 or -1. I'll go ahead and just divide out by the whole number there. So I get x minus 1 over -2 equals the cosine t, and y plus 2 over -1 equals sine t. And then I'll now square both sides of the two equations. So I get x minus 1 squared over 4 equals cosine squared t, and y plus 2 squared equals sine t. And then adding the two equations together, that's a sine squared, will give me the following equation for the shape of the curve. I get x minus 1 squared over 4 plus y plus 2 squared, which if you want to, you can say over 1. It still means the same thing. And together that equals 1, because cosine squared plus sine squared equal 1. So that's the equation of the curve. It's an ellipse, and it's not a perfect circle because this has a different number underneath than this. So it'll be an ellipse where the x radius is 2 and the y radius is 1. It's also not centered right at 0, 0. It's shifted because it says x minus 1. That'll shift it over to x equal to 1, where if I plug in a 1 here for x, that'll make a 0. And it'll shift it to y equals -2. That's where the new center will be. And then we need to plot it from t equal to pi over 2 to 3 pi over 2. So there's a lot of double checking that goes on here for free, because I'll draw the dotted line outline of the shape, and then I'll plot some points for pi over 2 and 3 pi over 2, and maybe something in between as well. And then I'll see that the points that I plot should land on the picture that I drew, so it'll be a double check that I get the right picture. It's almost impossible to get that picture wrong, because if it doesn't agree, then you know you made a mistake. So here's the picture of it. It's a y equals -2 and x is equal to 1. So here's a x and y axis. Make that a little higher. So let's say this is 1, 1, 1. So here's the center, and it has a radius of 2 in the x direction. So actually it'll go all the way over to here and all the way out to here. Well, radius of 2, even further out to here. So I should find that point and that point. And it has a radius of 1 in the y direction. So here's my center, and it goes up and it goes down. Now it might not hit all of these points, So I should just make them lighter. I haven't decided yet what the points are going to be for sure. But this is the shape of it, this ellipse. There, not perfect, but all right. So this would be x equal to 1, y equal to -2. There's -1, there's 0 in the middle. X-axis, y-axis. And that's the shape of the curve. Now I need to figure out which parts of it get filled in. Make it prettier. So I'll plot some points, t, x, and y. I definitely want to plot the pi over 2. And then I have 3 pi over 2. So I'll definitely plot pi and 3 pi over 2. And it might be smart to also draw a picture of the x versus t and y versus t. I might run out of space, but I can also just think about what they look like to make sure that I'm getting it pretty close to being right. So let's see it. Pi over 2. That cosine is going to be a 0 there. And then maybe I have room to draw these two. So I'll keep my chart here. Actually, so when I draw these little mini charts, it's nice to look back and forth because it helps me to plot the correct points as well. So 1 minus 2 cosine t. That would be the shape of the x. That's going to be like cosine, only it'll be larger, shifted, stretched by 2. It'll be upside down because of the minus, and then it'll be shifted up 1. So first it'll be stretched down to -2, and then shifted back up to a -1, and it'll be stretched up to +2, and then shifted up another 1 to 3. So let's see here. Here's a little picture of that. Here's t versus x. So, like when you plug in 0 for it, you get usually cosine is equal to 1, and then if it's times 2, it'll be there at 2. But if it's -2, it'll be down here. -2 but then pushed up to 1. So it starts out here, and then I'll show the regular, the usual picture of cosine would look like that. But then it's been stretched and flipped upside down and then shifted up. So this will be one. The new center is going to be here, and it's going to go all the way up to here. So it'll look like something like that. And that's 2 pi. Here's pi in the middle, and then here's 3 pi over 2. And pi over 2 back here. So that's the basic shape of x versus t from pi over 2 to 3 pi over 2. But now I need to double check and see if I'm getting those exact points, and then I'll fill them in. So at pi over 2, cosine is usually 0, and so the answer is 1. So there's that point at pi over 2, and x is equal to 1. And then I have to do y. Let me finish the x values though first. At pi, cosine is usually -1, so it'll be a +2 plus 1 gives me that 3 up there. So there'll be a 3 at pi. And at 3 pi over 2, cosine is usually 0 again, so I'll be back to 1. Then for y, have to draw that little picture too. That -2, so it's going to be shifted down 2, but it's also the upside down sine graph. So this is quite an exercise in itself, but I'll do it. That's a T again over there. I'll do it kind of fast. Sine, the usual sine graph looks like this. This one is flipped upside down, and then it's dropped down by 2. So it actually starts off down here at -2, and it goes down instead of up. And since it's dropped by 2, it will only get up to there. So that's the graph of y versus t, roughly drawn. And so when I plug in pi over 2, sine usually gives me a 1. So here's pi over 2, and this would be 3 pi over 2. So sine usually gives me a 1. Then I would have -1, so I would end up with a -2 minus 1, or -3. So yeah, that's where I am down there. -3. When I plug in pi, sine gives me a 0, so I have -2. Yeah, that's in that middle right there. And when I plug in 3 pi over 2, sine gives me usually gives me a -1. That's when it's below the axis. And so I have -2 plus 1. So I get -1. Yeah, that's where that's supposed to be. -1. Okay. All right, now I've plotted those points, I can put them on my ellipse, because that's the shape that I'm actually working for. So all of these go to the final picture. There we go. And at pi over 2, it's x equals 1 and y is equal to -3. So 1, -3. That's where we're at. That's the -3 down there. Then at t equal to pi, x is equal to 3 and y is equal to -2. So 1, 2, 3, -2. Yeah, I'm landing on the picture, so this is the double check that it's working. So it looks like that I've gone from this point to this point. And I have. There's a couple of things to notice about that. I mean, how do I know I didn't go around the long way? Well, for one thing, I can see that this is progressing at the same speed as radians, even though it's not really referring to radians at all, because it's nothing to do with radians on this picture. It's just it's taking cosine and sine at the standard speed. It's not multiplied by any constant numbers inside of there. And for another thing, I look at the pictures. So as I go from the starting point, which is here, and here at pi over 2, it says that my x is going to increase, so I can't be heading in the negative x direction, I have to head in the positive x direction, while y is going to also increase. So that narrows it down. X is increasing and y is increasing, then it must be filling in this line right here. Nice and dark. So far, that got me to pi, and then last I'll plot the 3 pi over 2. So I'm guessing that's the top one. And it says 1, -1, 1, -1, yeah. And at this point, if I look at these little pictures, x drops back down to 3 pi over 2, and y continues to climb. So yeah, x drops back down, but y continues to climb. So it goes around there and to there. So that's the actual curve. You can mark these as t equals pi over 2. Put a little label on that. Make the pi visible. And t equals 3 pi over 2 at the top. Yeah, put it in there somewhere. and that's the full picture.